Good afternoon. My name is Kishor Chauhan, Assistant Professor in BCA Department in IIMT College of Management, Greater Noida. Today my topic is SDLC, Software Development Life Cycle. Software Development Life Cycle, SDLC, Software Development Life Cycle is the part of software engineering. Basically, software engineering is a discipline whose aim is the production of quality software that is delivered on time within budget and satisfy its requirement. Software development lifecycle (SDLC) is a process used by the software industry to design, develop, and test high quality software. The SDLC aim to produce a high quality software that meets or exceeds customer expectation, reaches completion within times and cost estimates. It is also called a software development process. Software engineering basically have some advantage like as improved requirement specification, improved cost and schedule estimates, improved quality, better use of automated tools and techniques, less defects in final product, better maintenance of delivered software, well-defined process, improved reliability, and improved productivity. Basically, SDLC is a process followed for a software project within a software organization. It consists of a detailed plan describing how to develop, maintain, replace, and alter or enhance a specific software. The life cycle defines a methodology for improving the quality of software and overall development. Software development life cycle have different types of phases like as project identification and selection, project initiation and planning, design, coding, testing, implementation, and maintenance. Technically, we discuss all stages. Stage 1, planning and requirement analysis. Defining requirement, designing the product architecture, developing the product, testing the product, development in market maintenance. The first stage of SDLC is planning and requirement analysis. Requirement engineering is a process that involves all the activity required to create and maintain a system. Requirement document, Requirement engineering provides the approximate mechanism for understanding what the customer wants, analyzing need, feasibility, a reasonable solution, specifying the solution, validating the specification and managing the requirement as they are transformed into an operational system. Basically, the software engineering process involves the following activities, like as feasibility study, requirement electration, requirement analysis, documentation or requirement specification, review of user needs, management of user needs. Basically, requirement analysis is the most important and fundamental stage in SDLC. It is performed by the senior members of the teams with input from the customer. The sales department, market survey, and domain expert in the industry, this transformation is then used to plan the basic project approach and to conduct project feasibility study in economical, operational, and technical area. Basically, next phase, defining requirement. Once the requirement analysis is done, the next step is to define the document, the product requirement, and get them approved from the customer or the market analyzed. This is done through an SRS, software requirement specification document, which consists of all the product requirements to be designed and developed during the project life cycle. Next phase is design the product architecture. Basically, design phase of software development deals with transforming the customer requirement as described in the SRS document into a form implementable using a programming language in order to be easily maintainable in a conventional programming language. In designing phase, have different modules, like as different module required to implement the design solution, control relationship among the identified modules, that is the call relationship, interface among different modules, that is details of the data item exchange among different modules, algorithm required to implement the individual module. Basically, design phase have three types, like as architectural design, high level design, and detailed design. Architectural design is the highest abstract version of the system. It identifies the software as a system with many components interacting with each other. At this level, the designer gets the idea of proposed solution working. And second one, high level design. The high level design breaks the single entity multiple components concept of architectural design into less abstract view of subsystem and modules and depicts their interaction with each other. High-level design focus on how the system, along with all its components, can be implemented in form of module. It's recognize modular structures of each subsystem and relationship and interaction among each other. And next, detailed design. Basically, detailed design deals with the implementation part of what is seen as system and its subsystem. In the previous two implementation, it defines logical structures of each modules and their interaction to communicate with other modules. So basically design have three types: architectural design, high level design, and detailed design. Then next phase is developing the product. In this stage of SDLC, actual development start and product is built. The programming code is generated as per DDS during this stage. If the design is performed in a detailed and organized manner, code generated can be accomplished without much hassle. The goal of coding or programming phase is to translate the design of system produced during the design phase into code in a given programming language like C, C++, Java, Pascal, etc., which can be executed by a computer that perform the computation specified by the design. During this phase, design specifications are converted into executable statement. The next phase is testing the product. This stage is usually a subset of all the stages, as in modern SDLC models. The testing activity are mostly involved in all stages of SDLC. However, this stage referred to the testing only stage of the product, where product defects are reported, tracked, fixed, and tested until the product reaches the quality standard defined in the SRS. Basically, software testing have different types, like as unit testing, integration testing, system testing, functional testing, acceptance testing, smoke testing, regression testing, performance testing, security testing, user acceptance testing. There are some types of testing. Now we discuss unit testing. Actually, unit testing is a method of testing individual units or components of a software application. It is typically done by the developer and is used to ensure that individual units of the software are working as intended. Next, integration testing. Basically, integration testing is a method of testing how different units or components of a software application interact with each other. It is used to identify and resolve any issue that may arise when different units of the software are combined. The next one is regression testing. Basically, regression testing is a method of testing that is used to ensure that change made to the software do not introduce new bugs or cause existing functionally to break. Next one is smoke testing. This, this test is done to make sure that the software under testing is ready or stable for further testing. It is called a smoke test as the testing of an initial pass is done to check if it did not catch the fire or smoke in the initial switch on. Next one is alpha testing. Basically, alpha testing is a type of validation testing. It is a type of acceptance testing which is done before the product is released to customer. It is typically done by QA people. Next one is beta testing. A beta test it conducted at one or more customer site by the end user of the software. This version is released for a limited number of users for testing in a real-time environment. Next one is system test. Actually, system testing is carried out on the whole system in the context of either system. Requirement specification or functional requirement specification or in the context of both. The software is tested such that it works fine for the different operating system. Next one is stress testing. In this, we give unfavorable condition to the system and check how they perform in those conditions. Performance testing. Basically, it is designed to test the runtime performance of software within the context of an integrated system. It is used to test the speed and effectiveness of the program. It is also called load testing. In it, we check what is the performance of the system in the given load. And next one is object-oriented testing. This testing is combination of various testing techniques that help to verify and validate object-oriented software. Next one is acceptance testing. Acceptance testing is done by the customer to check whether the delivered product before the desired task or not, as stated in requirement. Software testing have many advantages, like as improved software quality and reliability and performance. Actually, software testing improve software quality and performance and reliability. Early identification and fixing of defects. Improve customer satisfaction. Increase stakeholders' confidence and reduce maintenance cost. The next phase is maintenance. Actually, maintenance part is the important part in SDLC. Once the product is tested and ready to be deployed, it is released formally in appropriate market. Sometimes product development happen in stages as per the business strategy of that organization. The product may first be released in limited segment and tested in the real business environment. UAT, user acceptance test. Then based on feedback, the product may be released as it or with suggested enhancement in targeting market. After the product is released in the market, its maintenance is done for the existing customer base. Software maintenance have many key aspects like as bug fixing. Bug fixing is the process of finding and fixing error and problem in the software. Next one is enhancement. The process of adding new features or improving existing features to meet the and involving needs of the user. The next one is performance optimization. The performance of improving the speed, efficiency, and reliability of the software. Next one is porting and migration. The process of adapting the software to run on new hardware or software program. Hardware or software platforms. New software platform like has different types of software, system software like as operating systems. And next one is re-engineering. The process of improving the design and architecture of the software to make it more maintainable and scalable. Documentation. The process of creating, updating, and maintaining the documentation for the software, including user manual, technical specification, and design document. These are some key aspects of software maintenance. Now we discuss types of maintenance. Basically, software maintenance have 4 types, like as corrective maintenance, adaptive maintenance, and perfective maintenance, and preventive maintenance. Now we discuss first one is corrective maintenance. The corrective maintenance, this involves fixing error and bug in the software system. Next one is adaptive maintenance. Adaptive maintenance, this involves modifying the software system to adapt it to change in the environment, such as changes in hardware or software. Next one is perfective maintenance. This involves improving the functionality, performance, and reliability of the software system. Preventive maintenance. This involves taking measures to prevent future problems. Thank you.